Good day to you coders, and thank you for supporting us on Project Collaborate. In this video, we'll be discussing sorting. So how exactly do we sort an array? So you can do this algorithmically, or you can just use a method. So the first way we'll be going over is just using a special method within the arrays class that you can actually use to sort. So first, you will want to import Java utilities or import java.util.arrays, either one, and then you want to use the sort method. So if we have an integer array, 1, 2, 6, 4, 5, 2, 8, 1, we can then do arrays.sort, and then in our parentheses, our argument would be array. And then our final array would be completely sorted numerically, so it'd be 1, 1, 2, 4, 5, 6, 8. And that's how you would sort an array. For an array list, there's something very similar, but it's actually in the collections framework rather than in the arrays class. So you would want to import Java collections or Java utilities. So import java.util.asterisk or import java.util.collections. And then you can use the sort method that way. So in this example, we have an array list with the integers of 9, 4, and 7. Then we can do collections.sort, and we would put our array list as the argument, and then our final array list would be 4, 7, 9. So there's actually another way of doing this, and it's more algorithmically. It's more coding it yourself rather than just using a single method. So the first method is known as bubble sort, and so all this essentially does is you're comparing adjacent elements, and if an element that has an index of n plus 1 and it's less than the element that has the index of n, then you would just switch those. So for example, if I have 3 and 1, since 1 is less than 3, I would switch it and it'd be 1 and 3. So we continue doing this until you don't require any more swaps. So our example here, we have an array 3, 7, and 2. So the first thing we want to look at is 7 less than 3? And no, so you don't swap. Then you look at, is 2 less than 7? Yes, so you swap the elements. And then the next thing you're going to do is you're going to say, is 2 less than 3? Yes, you swap the elements. And then your final array will be 2, 3, 7. Next we have insertion sort. And for this one, all you have to do is take a subset of a sorted array. And then you have to move the unsorted elements to the respective positions. So we have an array, we have 1, 7, 9, 3. So if you'll notice, the first 3 terms are actually sorted, so that will be our subset. So we have 1, 7, 9 as our subset. And then we look at the 3. We see, is it smaller than 9? Yes, so we swap. Is 3 smaller than 7? Yes, you swap. Is 3 smaller than 1? No, so you don't swap. And therefore your final array would be 1, 3, 7, 9. So you're probably wondering, why do we have so many sorting algorithms? Isn't one sufficient? So there's a thing in computer science known as time complexity. And each algorithm has its own time complexity. So the average time complexities for actually both bubble and insertion sort is O to the n squared. And that's like a special notation called big O notation. And so time complexity tells you the amount of time it's necessary to run an algorithm, where n represents the size of the set. So there's actually several types of time complexity, but so our first type of time complexity we can look at is O to the 1, and all that means is regardless of the size of the set, the time that it'll take to run the program will be the same. And then O to the log of n, that just shows that as you increase the size of the set, the time to take it to run it will increase in a logarithmic fashion. And then our worst time complexities are O to the n factorial and O to the 2 to the power of n. And those are just like the relationships between size of set and the time it takes to run it. And with that being said, that's all we have to cover in this video. If you guys have any questions, drop a comment down below or join our Discord server. Thank you for watching.